our Gradle build times started getting ridiculous, around 20 to 40 minutes for a single line change.
Holy moly.
Oh,
No more going to coffee. Go to get lunch.
I know. I know.
I mean, if you guys think this is bad, you should look at Swift build times. I don't know if you have any iOS friends.
From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker.
And I'm Kaushik Gopal.
Welcome to the show. So Kaushik, how you doing?
I am doing good, sir. How has your day been?
My day has been fantastic. It's just another day in paradise, as they say.
Another day in paradise. That sounds pretty good. My day was interesting. I had a pleasant Uber ride, but as you know, it took me a quick minute to get here. And so, speaking about Uber,
Yeah.
I hear we have an excellent Uber engineer with us today. You were telling me. Do you want to tell us more?
Yeah, so without further ado, I'm just going to hop right into it. We'd like to welcome Gautam to the show. Gautam, welcome to the Fragmented podcast.
Thanks for having me, guys.
Now, Gautam, I think it's best that for our listeners to become familiar with you, and I think the best way to do that is if you could give us a little bit of background information on yourself, kind of maybe how you got into Android development, where you work at now, and what you've been up to.
Sure. So my name is Gautam. I've been an Android developer for about 3 years now. So my first job out of college, I joined this company called Lookout Mobile Security. I'm sure you know some people from that company. There's a guy called Israel.
Oh,
That
yeah.
works at Twitter now.
Oh, hey, he was on the show before.
Yeah, I used to work with him a while back. And when I joined the company, I didn't know anything about Android. I did a bunch of Ruby on Rails stuff back in college. And I wasn't really sure about mobile dev, but I was given the job and I was in a growth team. And starting with Android UI, I think one of my first projects was designing a live wallpaper.
Oh, interesting.
Yes.
You guys know those. Those used to
Yeah.
exist a while ago. So eventually, working at that company, I started to develop an interest in a bunch of the Android tooling, especially around CI and the build system. There's around the time when we didn't have Gradle or any of the tools that we have today. It was mostly Eclipse. I don't know if you guys ever developed an Eclipse.
Oh, boy.
Man.
Yeah.
It's like you say that word and it just brings back nightmares for me. Like, okay, clear errors, clear output window. Oh, yeah.
Exactly.
Yeah.
And we were using AND back in the day. We were not even on Maven.
So all that good XML stuff.
Exactly. Yeah, it was interesting times. At that point of time when Gradle came out, I was pretty interested in the build system, all the new stuff that's coming out. I think it was during Google I/O they announced it and started diving into that stuff. I migrated our build system over at that company to Gradle and kind of like grew into more of a tooling background. And when I was starting to look for another job, I landed at Uber. And the first thing I told during my interview was I wanted to make tools for developers. And today I'm on the Android developer experience team at Uber. We focus a lot on things like the build system, the IDE, and any general productivity tools that developers use on their day-to-day jobs and how we can help them do their job better. That's kind of like the gist of my Android experience.
So you help the Android team at Uber do their job more effectively. Is that correct?
That's correct.
That's interesting. I had no idea that there was even a position like that at Uber. That's cool.
Yeah, so it was a very organic thing. I was on the platform team before, which used to coordinate a lot of the core libraries like networking, experimentation, analytics, etc. And since my main passion was in tooling, I kind of carved this team out over time. And we have a couple of people on this team right now. And I think this sort of team becomes very important as you scale a company with a lot of developers, especially you get a lot of unique challenges and problems. And I think we have a couple hundred Android engineers at this point at Uber.
Oh, wow. I mean, that explains a lot of stuff. That seems like paradise.
Yeah, there's a lot of smart people. And when there's a lot of people committing code changes, people tend to step on each other. So we want to make sure that they're doing their job effectively. At the same time, are able to commit fast and like move pretty quickly. So that's where we come in.
Yeah, now suddenly like the whole Android developer experience team is like, oh my God, obviously we need someone who sort of like helps with that.
Yeah, it won't be much of an Android developer experience team with just 2 engineers.
Holy cow, that's amazing.
One of the topics that both Don and I have been like really interested, and it's something that we've always wanted to talk about, is the whole buck system, right? So it's kind of interesting because I know that Uber now uses like buck, and so it looks like you've transitioned from like Gradle to buck, right? Is that true? Like, did you ever use Gradle, or was it always like did you folks jump onto buck?
To give you a bit of a background about kind of like how our build system evolved over time. So when I joined the company, there were maybe like a handful of engineers, and we had a very small code base with the rider app, the driver app,
Right.
and we had one common library, which was conveniently called Android library.
Right.
Yeah, so that was kind of like the shared code or glue between these two apps. There was no versioning for that artifact. So what people would do is it would be like a sub-module sort of situation.
Right.
Oh,
You would
man.
consume it and you would build off of it, basically.
Mm-hmm.
Yeah, so those are like the dark times at Uber. So when I joined, I wanted to basically get us off into like a system where we could add more of these libraries easily and start breaking things apart. So we started looking at things like Artifactory, which is like a Maven server that can host your artifacts. And we already had Gradle with a very basic setup. So we were pushing all our libraries up to the artifact server, and all the apps were consuming them, right? And organically over time, we grew to a situation where we had about somewhere close to 100 libraries with a lot of different functions that they do.
Wow.
And things started getting interesting.
So I got a question about that. I have a friend who was very early on at Uber as well, and he was telling me that that everything is based like microservices there. Do you guys find the same thing happens in the Android ecosystem too? Like everyone creates these like little micro libraries for various different components, or what?
To answer that question, I think when we initially started out, we had a macro situation where we would try to dump all our common utility code, anything that could be abstracted away into this library concept.
Yep.
But we later realized that if you start doing that, there'll be a lot of tight coupling, and that can be a very big tech debt. So what started happening is we started splitting out into sort of like what you said, like micro libraries, but not to the extent that there's only like 2 or 3 classes in that library. That'll just get ridiculous to maintain over time. So if you think about like a high level, you'll probably have a bunch of different components in an app. Stuff for networking, threading, UI. You'll have things for analytics, experimentation is one of them, and mapping and navigation, things like that. So we started splitting out our libraries based on the core feature aspects of the app.
Interesting.
That makes sense. How many submodules does like a typical app like of the size of Uber have?
It's totally dependent on the particular app, right? So some apps actually, when they were being developed, they didn't really have too many modules in their repository. There were other modules outside the repository. So we had a very multi-repo setup.
Gotcha.
So they would all build individually and upload to this artifact server, and then we would later consume it in a different place.
You guys, I mean, you have a ton of modules and libraries you're consuming. So at some point, you have to run into some type of scaling issue with Gradle. I mean, or does? I mean, I haven't ever had that many submodules, and most developers probably haven't. I guess the big question is here, did you guys run into any scaling issues with Gradle when you reached that type of level?
Sure.
I mean, I remember a project I worked on that had just like maybe 3 submodules, and it was already a nightmare in the early days of Gradle. It was super, because I'm like really curious to find out what's like, I imagine there's more than 3.
Yeah, definitely more than 3.
So how has that worked out? Yeah.
To answer that question, I think initially when you start out like a new project in Android Studio, the wizard kind of tells you like, hey, there's this app module that you can make, right? I'm sure if you start with like a hobby project or like something on the side, you'll see like one module. And the interesting thing about that module is as you start adding more code to it, every single change you make needs the entire module to be recompiled. And after a time, we do get to a state where small changes will take so much time that you're either going for a coffee break or doing a lap around the office.
Oh, yeah. We were just talking about that.
Yeah, we actually did that at Uber.
Or push-ups.
Push-ups, squats, whatever.
Yeah, whatever you fancy. And at that point, a lot of the engineers would say, hey, this is too big. Let's kind of like break it apart. And then they start breaking things apart, and then they'll start seeing something interesting. They see that their Gradle sync times start getting really slow. So whenever you make a change, you're like, oh my God, Gradle is saying to me that the project is out of sync. I need to resync this, but then it takes a while. So that can be like a very dreading proposition for engineers when you're working and you want to just keep working on your code base, right?
Right. Like, oh my God, do not change, do not add a space to your Gradle file, because then it's going to ask you to sync, and then that's going to be another 5 minutes, right?
Exactly. So that's the situation why I think we started putting stuff outside, because they are pre-built artifacts, which means that you don't need to rerun their tests or recompile them.
Right.
But that comes with other problems at scale, which means that if you have hundreds of libraries, it's very hard to make big refactors in a safe manner, unlike in an atomic way. So whenever you want to make a change in networking library, there could be hundreds of other libraries that depend on it that could be really problematic when you can break an API. And since everything is pre-compiled, you won't really see the problem until it's like a runtime issue.
Yikes, that doesn't sound too pleasant. Yeah, especially in terms of like discovering that problem, right?
Exactly. Yeah. So for a while, I think we are still kind of like in that system where we have a lot of dependencies. So to kind of like alleviate that pain, we have a system where internally whenever some dependency changes, we recompile and retest all the code for that particular version to make sure everything is compatible. But that gets like gnarly as well when you have a lot of dependencies.
Right.
So at some point, what happened was our Gradle build times started getting ridiculous, around 20 to 40 minutes for a single line change.
Holy moly. No more going to coffee. Go to get lunch.
I know.
I mean, if you guys think this is bad, you should look at Swift build times. I don't know if you have any iOS friends.
Yeah, 20 minutes is dysfunctional, right? I mean,
Exactly.
wow, that's like half an hour. Like, how does anyone get any work done? Damn. Okay.
So yeah, so like I think back in May when we started like kind of seeing this issue. So I don't know if you guys have used the new Uber app. Have you guys tried it out yet?
But you mean the new Uber app that came out, like the redesign? Yeah, it's pretty
I
slick.
used it yesterday, yeah.
Yep. So that app actually started out around that time. It was a brand new architecture where a lot of the core principles relied on the code being broken apart into a lot of modules. And this is very worrying for me, being on the Android developer experience team, because I was like, the platform team wants to like bring out this cool new architecture, and they have a lot of these modules coming up, but then the build times are going to suck. And so I don't want to like stop them, right? Like I don't want to stop them from like progressing. But
so what do I mean? You get to this level, you break everything apart, you have all these modules, you have this humongous build time. What do you guys do at that point to speed everything up?
We didn't even think about speeding it up. At first, we were just waiting, trying to see if we can make it work. So we talked with the Android tools team quite a bit, and we tried to see if we could scale Gradle for the longest time. But then we realized at some point that it doesn't scale. So we started looking at other companies at that scale. We started looking at companies like Google and Facebook and Twitter, and like they have this gigantic mono repos with a lot of code,
Yeah.
but they're still functional. So it got us interested in like what they are using to build their code bases. So at that point, I think when we evaluated some of the alternative build systems out there, there were a couple of different contenders. There was like Buck from Facebook. There was Bazel from Google that they open sourced.
Oh
And
yeah.
there was also Pants from Twitter, I believe.
Forgot about that one.
Just so I understand, and like so it's clear to our listeners, these are like alternatives to Gradle. So these are like all completely one-to-one build systems.
Yep, they're all independent build systems that can build a lot of different Java or mobile code bases, but they are all built by different companies.
All right.
Interesting.
Bazel, you said the one that Google open source. Does that have anything to do with Gradle? Like, I mean, so Gradle is like independent. I know it's not part of Google, but that was something that a common question that could come up with the listeners. Like, well, then there's Gradle and there's Bazel. So, like, does Google not internally use Gradle, and do we know, or do they use Bazel? Like, where does that play in?
Sure. So there's two different things, right? There's Gradle, which is the build system, and then there's the Android Gradle plugin, which is basically a plugin that lets you build Android projects with Gradle. So if you treat it separately like that, it kind of starts making sense, right? So Gradle is something that was open sourced by a company called Gradleware.
Right.
And it was at that point of time, I believe, very easy for small projects to start getting bootstrapped very quickly. So the Android tools team at that point of time decided it's a great idea for external developers to start using the system because it's very low friction. And at that stage, Bazel was not open sourced yet. So they had something called Blaze internally, which they currently still use. And a lot of these systems that I just talked about, Buck, Bazel, and Pants, are all designed by engineers who left that team and moved on to different companies. And they kind of built a very similar system based on Blaze that Google uses internally to build most of their code base.
Oh, interesting. That's good to know.
So as I was saying, when you started looking at these alternatives, we kind of like wanted to focus more on something that would work really well for mobile and Android specifically, right? And at that point of time, Buck was probably the only one which had a lot of the features that we kind of get for free in the Android Gradle plugin. So that was something we started taking a closer look at that point of time. And it had like really good features, right? So it promised so many different things like really fast builds, uh, incremental builds supposed to be really quick,
Mm-hmm.
a lot of customizability, and build for scale for the code base is the size of Facebook.
If you're speaking fast, like, can you like, do you have an approximate idea of like how fast? Like, is it 2 seconds faster? Is it like 1 minute faster? Is it 2x faster? Like, do we have an idea?
Or taking like the Uber stuff, like how long your guys build is now compared to how long it was before. Anything.
So I'll give you like a kind of breakdown of different phases with Buck, right? So when we started looking at Buck, we did everything initially by hand. We wrote all the different configuration files for Buck, and the build times were maybe like 2 to 3x of faster than what Gradle gave us.
Wow.
Oh,
So
wow.
very early on. And when you do incremental builds, especially, there's a lot of different optimizations Buck makes. There's a thing called Exopackage, which is something very similar to multitext, and this is way before multitext existed, which kind of like uploads the change class files to the device whenever you try to rebuild project after you change some Java files. So that kind of like cuts down the build speed even further, and we started seeing like maybe 6x improvements in build times.
6x. Holy cow. Okay. So just to backtrack a little, is this similar to like what happens with instant run now in that case?
Yeah, I was
Yep.
thinking the same thing.
Yeah, so instant run is very similar, but it does have a bunch of limitations, especially if you start looking at instant run. When it has anything to do with annotation processors, it basically does a full rebuild. Purely because annotation process that a lot of the Android community uses these days, like Dagger or Butterknife, they require the entire state of the code. So anytime you change a file, it's very hard for the instant run to predict what's actually supposed to be rebuilt. So it has to run the annotation processor again and has to rebuild the code again. So a lot of the samples you actually see from instant run don't have annotation process turned on, if you noticed.
Oh, interesting.
Enlightenment just hit.
I know, yeah. So how does Buck handle that then? Because like I imagine it's the same thing. Like nothing has changed about the
Yep,
annotation
exactly the
processes,
same.
right?
So Buck takes a different approach to this, right? So Buck says incremental builds are very hard to do in general, because if you looked at the world of Ant back in the day, it used to do incremental builds which would give you 98% of the time correct results, but 2% of the time you'd have to do like a full build.
Oh god, that happens even today, and it's like super
Exactly.
frustrating.
So with Buck, what they did was they preferred very small reusable modules, so any individual unit can get really quick to build or rebuild,
Mm-hmm.
which means that you have a lot of flexibility for how long you mean how much you want to scale your build process. So let's say that you have one big giant application module today in terms of a Gradle module. The moment you see that, hey, there's some parts that are not required to be recompiled every time, you can start splitting things out. And there are some modules in which you don't even have to run annotation processors, for example. So as you start splitting things out, the build time becomes like a function of how small you can get the modules and how many of them you can actually build in parallel. Which brings us to the next point about Buck, which is that it is very heavily based on input and outputs
Okay.
compared to Gradle, which is task based, similar to how Ant was. So what that means is like it treats every rule that you're saying. Let's say like you want to build like an Android library. The way it builds it is it looks at all the different inputs that are required. So things like resources, sources, other dependencies, and it says, hey, is all the dependencies currently being ready for me to start building this rule or not? If it's not built, then it'll go down one more level and it'll try to build the ones that are further down. So it's a very simple execution model, and it can parallelize really well. And that's what makes it like very input output based. So there's no more like task model. It's just like I have these set of inputs, what's the expected output, and that output can be input to another rule.
So here's a quick question then. You said it sort of like encourages like using more smaller sub modules, right?
Mhm.
Does that mean when I write a generic application, would it serve me better to like force myself to like use these sub modules, or does that not necessarily matter? And then the alternative question is like, well, if I didn't have sub modules, then am I not going to see a benefit with Buck?
So this submodules definitely help you with the build times, but they're not the only way that Buck is faster. So when I talked to you about the parallel execution model,
Mm-hmm.
So since this parallel execution model is very, very fine grained, right? So all it cares about is what's the input and what's the output. So if you have multiple modules, kind of like how Gradle parallel, like Gradle has a switch called parallel build that you can turn on. It's kind of similar to that, except that Buck makes really good use of all the cores in your machine, and it kind of like understands what is like a best way to run all of these targets. So even when you have like a vanilla Gradle module, setup, and you haven't really spent time to split it up, you still typically see gains of like 2 to 3x from like for a clean build. So to actually prove that fact, we have a test project on GitHub that I think we'll link for the guests, that kind of like shows how the different build systems stack against each other. So you can actually build the same project with Gradle and build the exact same thing with Buck, and you can kind of see for yourself like the clean builds how it makes a big difference. And since everything is kind of like declared beforehand in Buck, so input and output, there is no such thing as a Gradle configuration time. So because I don't know if you ever saw this like Gradle configuring projects X of Y.
Right.
You just wonder like what is it actually doing in the background. So it's doing a lot of stuff to like configure the tasks and kind of like figuring out what the inputs are, outputs are, but all that stuff is kind of like pre-given to Buck, because the build language it uses actually makes it very easy for it to actually skip the entire configuration phase.
So that's like, again, an interesting thing. So you said it's highly customizable, and then you mentioned the build language, right? So Gradle is written in Groovy, right? So Groovy is the language that's used. Does Buck also use a language, or is it more declarative like Ant or Maven?
The Buck build files, they call them Buck files, are actually mostly just Python rules with some macros, if you think about it that way.
Oh, interesting. Okay.
You can actually write Python in the Buck files.
Do you know what the Buck build system is written in? Is it just purely Python, or what is it?
The actual build system is written in Java.
Oh, cool.
I know Java.
Yeah. More groovy. Yes.
Correct. So even actually Gradle, most of it is actually written in Java nowadays. The older versions of Gradle were written in Groovy, but almost 90% of Gradle is currently in Java. There's very few parts that are written in Groovy nowadays.
Oh, interesting. And it's surprising though, because like Groovy, I guess that's like more of a familiarity thing as well, right? Because Groovy is supposed to be kind of a better language. Well, actually, I shouldn't say that, because better is...
Who are you talking to?
Yeah. Yeah, I probably am going to get a lot of thoughts on that.
But from what I understand, like Buck isn't just used for building Android. Like you can use it. It's a build system. You can use it to build Android or other projects like a Go project. Is that correct?
Yep. Yeah, it actually supports quite a bit of languages, and it's very easy to add new ones. So I think it natively supports like Java, Android, iOS, Objective-C, like Swift is kind of like in the works right now. C++, a bunch of other stuff like Go, Rust, Haskell, what have you, right?
Have you found folks actually use, like, I imagine Facebook is using this for their iOS applications, but have you seen Buck being used for like also other like iOS applications?
Sure. Actually, the iOS team at Uber, so we have a counterpart called the iOS developer experience team. They migrated to Buck before we did for Android. So we basically have both iOS and Android builds orchestrated in Buck and at Uber.
Gotcha.
And the other thing that kind of like is really nice about Buck, which I have to quickly mention, is it's really good at caching stuff. And since it's based on the input-output rule, if inputs haven't changed, it reads the output as up to date. Kind of similar to Gradle, but the checks are like a lot faster, and they're not based on timestamps. They're actually based on the file content, which means that let's say you make a build right now and you change a file and you do a build, and then you later change your mind and then you want to like go back to the previous state and you build again. So what happens then is it basically says everything's up to date because it's already previously built that state of the code base.
That is so cool.
Yep.
So, and how does it do that? It doesn't look at timestamp. So you're saying it looks at file. Does it like have a hash or something?
Yep. It maintains a hash, and it also does something very clever called there's a file watching service it uses called Watchman that goes in the background like a daemon and kind of figures out that, hey, these files which are part of this target have changed. I need to tell Buck, like it kind of like knows before you even click a build that what's changed already. So it can take decisions really, really fast.
Interesting. So this is like an additional thing that you have beyond just like the regular Buck system. Like Watchman is what you called it.
Yeah, you don't really need it to build with Buck, but it actually makes it faster. So it's nice to have.
Okay, that's pretty cool. That's pretty cool. Now, I know one of the other advantages that's been mentioned about Buck is like reproducibility in your builds, right? So how does that work? Like, what does that even mean? Like, why is like reproducibility important? Like, why do you need that? It sounds like a good thing, but I mean, why do I need that in my builds, right? And like, how does Buck provide that?
Sure. So have you ever had a situation in your build or Gradle file where maybe you or another colleague adds like some configuration that depends on things like the git SHA? Kind of like a lot of people, I think, want to have like the SHA or like the version of the code base as part of their build config. So what they typically tend to do is they add it to the build config fields in Gradle, which means that every time you build it, the Java file change, the build config.java change, which means it'll end up doing a full rebuild. So basically, we're talking about state that is outside of the build system that you're trying to bring in. It's very easy to do with Gradle. And sometimes what you end up doing is you depend on like a jar that's in like the the JDK, like the tools jar if you're developing annotation processors. And those jars are actually different on every different machine. So your coworker could have a different JDK and you could have a different JDK, which means that what you're actually building might be slightly different in terms of output.
Oh, right.
Which means that the actual APK that you're building could be having some differences from what you might be seeing, which can be very frustrating when you have small changes which are very hard to debug.
Oh, for sure. I imagine. Yeah, yeah.
So with Buck, it's very hard to do because you pretty much have to like be very creative to have that happen to you. The way the build language is described,
Okay.
you can't depend on like environment variables. You can't like hard code strings that are like dynamic, right? So you can't really have like dynamic dependencies for that matter, the way you can do with Gradle that can change with every invocation. So that kind of like is part of the reproducibility, which means that if I check out a particular version of the code base and if I run it on any machine at any given point of time, I would always be guaranteed to get the same exact output.
And like what you're saying is this is not necessarily something that you can guarantee with Gradle at the moment.
Yep. I mean, you can actually guarantee it, but it's very easy to mess up. We had instances in our code base where we did this mistake ourselves, and while we started migrating it to Buck, we realized that, hey, why is this target being rebuilt every time? And then we kind of figured out, oh, it's because in Gradle, this is not really a problem because we were kind of used to it being rebuilt every time. But with Buck, it can get pretty annoying, especially when you're used to like really fast build times. Anything that
Right.
triggers that can be a problem.
So I'm an Android developer. You're an Android developer. Kaushik's an Android developer. And everyone who listens usually is an Android developer. And we spend all of our day inside of Android Studio. So anytime I hear about any of these new tools or things that I can use, the number one question that pops into my head is, does this work with Android Studio? Does Buck work with Android Studio?
So Android Studio is purely based off the excellent IntelliJ IDE by the JetBrains folks.
Mm-hmm.
So if you think about it that way, it does work. Actually, Buck does work with Android Studio, but you may not see all the like latest features that Studio might push out, right? So like for example, constraint layout is something that a new thing that Google pushed out, hasn't been upstream to IntelliJ for a long time, but now it is. The latest version of IntelliJ actually has constraint layout, which means that eventually these two end up in IntelliJ. But Studio definitely is something that people do want to use with any build system, right? It does work with Android Studio in like a limited capacity, but typically what we do at Uber is we use IntelliJ instead of Android Studio because we don't miss the Gradle sync times. With Buck, that's completely gone out of the picture.
Oh, okay.
So you use it with IntelliJ, but I mean, I imagine that means you can potentially also use it with Android Studio, right?
Yes, you totally can use it with Android Studio as well.
Okay, so we talked about some of the major pain points in the build system for a company as big as Uber and found out some of the cool ways in which Buck can offer some help. In the next episode, we'll actually dive into more specifics with okBuck, which actually makes it way more easier to add a build system like Buck to your Android project. So stay tuned for part 2. That's it for the show, folks. Fragmented is hosted by Don Felker and me, Kaushik Gopal. We edit all of the Fragmented episodes ourselves. The amazing Sarah from Spec helps us with production assistance and wraps our final mix. Our theme music and ad music is produced by the cool cat, Alan Taylor. You can find more episodes of the show on Pocket Casts, Google Play Music, or any of the other great podcast players in town. Our website is fragmentedpodcast.com, and you can find the links to all the stuff we say on our website. Thank you all for listening, and we will catch you in the next episode.